Hi everyone, in this video we will be looking at more simultaneous equations, solving them using the matrix method. So we have about 3 questions in this video that we're going to be going through, right? So if you need to look back at any videos before, one, you must need to know how to find the determinant of a matrix, the inverse of a matrix, and how to multiply matrices as well, right? So just go back and look at those videos. I have a video as well with the simultaneous equations from before as well. So let's just go ahead. So the first thing that we must do, we have to pull out. So this is our 2 equations are here. 3x plus 5y equals 7. 4x plus 3y equals 2. So first thing we do, we need to pull out the numbers. So the number before the x, 3, and then the number before the y, 5. And then the bottom, the second equation, 4 and 3, times xy, just like what we did before in the other video, is equal to 7, 2. And then xy is equal to the inverse of our matrix that we're carrying across, 3, 5, 4, 3 times 7, 2. So I'm just going to do the inverse of that matrix here. So remember the inverse, right, is, well, firstly, we need to find the determinant, right? So the determinant of this matrix, diagonal, 3 by 3, take away the product of the second diagonal, 5 by 4, so that's 9, take away 20, which would be minus 11. So our inverse, it's 1 over the determinant, 1 over minus 11, and they switch the matrix. So the 3's, well, they switch, but I mean, they still remain as 3, 3 because they're both the same. And the numbers remain the same, but we change the sign, right? Just like what we did from before. So now I have 1 over minus 11, that inverse there, multiply these 2 matrices. So let's go. Leave your 1 over minus 11 on the outside. So row by column, so 3, and the bottom minus 4 times 7 plus 3 by 2. And now we're just going to simplify there. 1 over minus 11, let's simplify the numbers inside, so that's 21 plus minus 10, then we have minus 28, minus 28 plus 6, yes, and then we could just finish up right here, 1 over minus 11, so 21, remember the plus and the minus gives you a minus, 21 minus 11, and then minus 28 plus 6 is minus 22, and then minus 11, when we multiply by each number inside, we will get minus 1 and positive 2. Remember, it will be 1 over minus 11 times 11, and then 1 over minus 11 times minus 22. I just skipped that step because by now you should know that, right? Any questions, any this message or comment, sorry, down below, and I could always attend to your question. So we have our next 2 pair of simultaneous equations we're going to solve using the matrix method. So let's just create or pull out our matrix from the 2 equations. So 2, and then before the y it's 1. So that's for our first equation. And our second equation, we have 1 before the x and then minus 2 before the y. And that's multiplied by xy, and that is equal to 7, 1. And now, so xy is equal to, we carry the of 2, 1, 1 minus 2 times 7, 1. And at the side, I'll go ahead and find the inverse, right? The inverse of the matrix and so on. So I'll just skip a step. I'm going to do everything in one, right? So it's 1 over the determinant. So that's 2 by the product of the 1 over the determinant, which is 2 by negative 2. Take away 1 by 1. So on the bottom, there's my determinant. And then after we switch the numbers in the first diagonal, so minus 2 comes here, 2 comes down there. And in the second diagonal, the signs and the numbers change. Minus 1, minus 1. Again, you could do it separately, like how I did it in the first question, finding the determinant separate and so on. Right? I know sometimes it's a little bit confusing this way. So here we get minus 4, minus 1, and then our new equation there. Well, minus 5 and minus 2, minus 1, minus 1, 2. So now we come back across. So let's just create a little barrier if we need it. Is equal to 1 over minus 5 by minus 1, 2, minus 1 there, times 7, 1. Again, we go ahead and multiply these two matrices. So xy is equal to 1 over minus 5. So now let's go to minus 2 by 7 plus minus 1 by 1. And then the bottom now, minus 1 by 7. I can simplify right here, actually. So then I get minus 2 by 7 is minus 14 plus minus 1. And then I have minus 7 plus 2. So now we'll get xy is equal to 1 over minus 5. So remember, plus and a minus becomes a minus. So this is minus 15. And the bottom we get minus 5, minus 7 plus 2 is minus 5. So then I'm just showing you all 1 over minus 5 times minus 15. So I'd have left out that step in the question before. And you don't have to put it in, you can final answer, which would be 3 and 1. Now, I would have mentioned this in the last video, so x is 3 and y is 1, right? I forgot to write down this final piece of the question before, but you all know the top number, bottom number is y. If you substitute your numbers into the equation, so x is 3, y is 1. So 2x, so 2 times 3 is 6, plus y plus 1 will give me 7. And likewise, x is 3, so 3 minus 2 by 1, so 3 minus 2 is equal to 1. Once you substitute your answers, your values for x and y into the original equations, you would see that once they work out to give you the answers on the right, they are correct. Now we have our last question, so let's plot out a matrix. So we have 3x minus y equals minus 10, 4x minus y equals minus 4. So the matrix, our 2 by 2 matrix is 3. Now before it, we have minus y, so it becomes minus 1. And then the bottom, 4, and then minus 1 again. Times xy, that is equal to minus 10, minus 4. So same thing like before, again, it's the same thing over and over, right? So the inverse of 3, 4, minus 1 times minus 10, minus 4. So again, I'm just going to do the inverse at the side, right? So 3, 4, minus 1, find the determinant first. So the determinant would be first diagonal, product of the first diagonal, 3 by minus 1. Take away the product of the second diagonal, minus. So our determinant is minus 3 minus minus 4. 2 minuses is a plus, remember that, right? So minus 3 plus 4 is 1, right? So therefore, my inverse would be 1 over 1 over the determinant, and then you switch the numbers in the first diagonal, and you change the signs in the second diagonal. So minus 1 becomes positive 1, 4 becomes negative 4. Alright, so let's come back across to finish it up. So 1 over 1, that's just 1, right? So they need to even put that. So minus 1, 1, minus 4, 3, times minus 10 is 4. And the last piece now, we're just going to multiply these two. 1 over 1, but just, it eliminates. 1 over 1 is just 1, right? Alright, so let's go and work on this. So row by column, minus 1 by minus 10, plus 1 by minus 4. And second row by the column, minus 4 by minus 10, 3 by minus 4. And let's just simplify that. So we get minus 1 times minus 10 is positive 10, plus 1 by minus 4 is minus 4. Minus 4 by minus 10 is 4 positive, which is minus 12. So therefore xy, number minus. So we get 10 minus 4, which is 6. And then we have 40 minus 12. So that will give us 28. Yes. Right? So x is 28. Now, again, you could substitute your values into here when x is 6 and y is 28. and then you will realize, okay, you'll get minus 10 and you will get minus 4 when you substitute in two equations, right? So try them out. I know it's a long process, but it's actually not hard. And as I said at the beginning, many students prefer this method over the algebra method because a lot of people don't like algebra, right? And that's totally understandable. So you just choose whichever method. You could use this method in section 1 when they ask if you get a pair of simultaneous equations in the algebra questions to solve. So that's an option, right? So that way you have to only learn it once, how to solve simultaneous equations. But again, it's totally up to you. Alright, so I'll see you all in my next video.